Seems like we are live again. So,
Woohoo!
Yeah, great day, right? Yes, glad to see that. It's a lot of people here as well, so that's cool. My name is Stefan Schörling. I have on my side Mr. Borg, Mr. Cyborg, or...
Yeah, that was the project name for our kid, not mine and Stefan's. Yeah, we just said, Henning asked me, where's your wife this year? Because I brought her last year. And I said, no, this year I have my work wife. One thing that's needed to launching and running these kind of events is sponsors. So big thank you to all the sponsors that make this happen. And to the organizers that also makes this happen, of course.
Yeah, a bit about me, Stefan Schörling. I live in Sweden, although my last name is kind of not Swedish-ish. But I work at Onewin. I'm the CTO. I also run our managed security services, which includes like 24/7 monitoring, threat hunting, incident response, and so. I've been in the Microsoft community for a while, hence my gray hair. Yeah, short about me.
I thought the gray hair was me. My name is Mattias Borg, work at the same company as Stefan, doing a lot of threat hunting, a lot of research, both offensive and defensive research, which is like super fun. And yeah, so the idea we had with this session was to give you some practical examples, some ideas, some inspiration, and yeah, maybe something you want to bring back home and test, do, use, whatever. So there's like a why in this. Red pill or blue pill? We want to, I mean, it's since it's data, we don't maybe run to the devices. Maybe we collect the data, but do we want to like poke all devices or system that creates data? No, we want to gather everything in a lake somewhere, and we want to query the data and work with it that way. So that's the reason why we, once again, going to choose the red pill. Someone's told us that we need agenda slides. I mean, should always have it.
And this session is going to be a bit of a roller coaster. We know there are some apprentices out there as well, getting into Kusto. So we're kind of starting off slowly, very slowly, I would say, and then we trying to ramp it up throughout the session here. But it's hopefully something for everyone, and especially those online. We know there's a lot of new people, just like they got started with PowerShell many years ago, are getting into Kusto. So that's how we're going about it.
There's going to be a bit ups and downs and some fun. See if someone can solve that crypto thing there at the bottom on the way. Yeah, the source code for it is in the background.
All right, so let's get into it. The where, the how, and the what, I guess. So kind of Star Wars, yeah. But I mean, Kusto is everywhere. I mean, we've seen it throughout the day. I mean, we have the Fabric, we have ADX, we have it in Defender, we have it in Intune, we have it all over. So we're trying to cover a few different places for different personas throughout the session in the end with a practical example. So it's not going to only be security persona focused, so giving inspirations to other roles as well who need to get into Kusto. We try to invite them online to see things. So we'll be a bit everywhere, but yeah, it is like Henning showed this morning. It's everywhere and it's massive. So it's core for many products today.
And was it like one CPU it's running on, or a few more?
Yeah, exactly. Yeah. So to start off with, for the apprentices, I mean, how do you go around writing queries? I mean, you start by selecting a table to query the data. You pipe the data to send data further. You select a column. You select some operators and start querying the data. I mean, if you worked with SQL before, it's kind of similar-ish. I think that's enough for that slide to get started for some people. For reference, we have a few operator slides, selecting and so on, just for people online to know and what they're being used for. I think we can just click through these, just for reference for those who are new to it. This is a function I use quite a lot because I use like visualizations with rendering data, showing data and seeing if there are spikes and so on. So that is also something for the new apprentices to get going with. And then there are some more advanced ones on the right-hand side, which Mr. Cyborg played with.
One thing I noticed when building this was at the bottom right corner. It's a representation of a WAV file. And I was working with it. I also realized that some function fur that is being used when you do audio, it's also in Kusto. So I could reuse stuff. And I also noticed that the chart, like scatter chart, works a bit different between where you are. So these, the picture things wouldn't work in Defender, but it works in ADX. And so it's important to understand, depending on where you are, you don't have like full Kusto implementation everywhere. But working with like a visual style, for me it's much easier to like see the data. And when you do graphing, to visualize it. Because reading like a huge table and try to find like what stands out in this table, it's much easier to draw a graph or timeline or whatever and see like the spikes, so you know where to look into. And you, yeah, of course, we have pie charts and, I mean, like bread and butter. That's why they're small in this picture.
Yeah, we saw this one at another conference and we said, well.
Are you sure?
Really? Well, it's in some implementations, sure. You query data, but I mean, you need to know where you are and don't use the drop table. But I mean, in general, in most of the products, you query data. You can't destroy things. So play around, but be wary if you're in ADX or other places, because you could definitely do harmful stuff as well. But so we just wanted to bring that up because so there's no misconceptions. So you could potentially do things.
There's also undo, which is like a good thing. If you accidentally drop a table, I actually did that before another presentation at another event because, hey, this is, I need to like reduce the cost a little bit on this ADX cluster. And I dropped a few tables that I needed for the presentation, which was a bit stressful.
Oh, that's when you called me. I had like 25,000 on my credit card or something. Yeah.
Yeah. That could be the one, actually. Yeah. Always use someone else's credit card. That's an important thing. And ask for permissions.
Yeah, so when your MVP credits run out, yeah, that's when it happens.
Yeah, and it actually happened myself this summer because I have had a lot of ADX clusters running in my lab environment. And I went offline during my vacation and, yeah, got a pretty nice invoice after that.
Yeah, I had a similar incident with external attack surface management with also similar amounts for 1.2 million assets in a demo environment. So, yeah, be cautious about your billing.
Love scripting. So statistical modeling. I mean, I'm not a like math expert. I like to analyze things and see how things changes when I change things in the code. And after some time, you do some read up, try to understand. I've seen formulas like the cousin similarities that Henning was mentioning. I can't even pronounce like the math for that because I didn't go to school basically. But I understand how the function works. And just to go back to the cousin similarities, I started to do research this summer to see if we could use that to find typo domains in email URLs. And it actually works depending on how long your domain name is. But there are some more research coming up on that. But statistical modeling is like relationship between random values and non-random values. And we use it to visualize the data and visualize these relationships to identify and predict an outcome. In Kusto, you can use forecast, we can use calculations for anomalies to see what actually stands out. And it doesn't matter how like small the changes are, we can calculate and increase the small changes to make it easier to visualize it. So we want to do like quick basics of anomalies. So when I ask you, like, do you know what an anomaly is? And everyone will raise your hand. And also for the people at home. But just to do the basics, I drink a lot of soda. Because, hey, we all do, right? So week 1, I drink the pink security soda on Monday. I do it on Tuesday. Haven't you tried this? It's really good, actually. Wednesday, Thursday, Friday. Yeah, now you can do forecast. Saturday, Sunday. But hey, this Thursday I drank a blue one, the blue security soda. Is this an anomaly? Yes. Well, it depends. It definitely is on this 7-day time scope. But then we are on week 2, week 3, and week 4. So where's the anomaly now? Anomalies always depends on the time frame that you do. So 100% right, it was an anomaly the first week. But then over time, it changed. And then the Thursday with the pink security soda and the bleeding one, they are the anomalies. To do anomalies in Kusto, we have a few functions, well, we have tons of functions, but to do time series, to put the values on the timestamps and see which value stands out over the time. And then we can do the decompose anomalies, we can do forecasts, so we can see what will happen after this, or what is expected to happen. For instance, amount of data ingested, what is the expected value and what was the reality. So we can see if we have small dips in the ingestion, or if it starts to increase. Maybe the small increase is nothing that the customer will care for that much at least. But if you see that, hey, with this, this increase that we have now, and if we look at the forecast, it will increase a lot, so maybe it's something we need to look into. Or if maybe someone changed an audit policy and we started to see a reduce of certain ingestions, so we can actually find these smaller changes in the environment. And there are tons of other functions that you can use that are super, super cool. And just to visualize it, we can see that, yeah, over here, definitely something happening. But we can also get this into a table. So we can print out where the anomalies are, and then we can join this with other data. Maybe some graph data that have been mentioned a lot today. So I really recommend you to look into this if you already do a lot of Kusto, to try to find what stands out. Instead of do like summer count per day, I mean that you can use that for very like simple anomalies, and when it's like super clear, but try to also adopt a calculation for the anomaly, and you will start to find really, really fun thing. As an example, it could be all the domain admin logons, and so everyone logs on 8 to 5 or something, and then suddenly one domain admin logs on 3 o'clock in the morning, or which devices they log on to. So you can see which, in all this like massive lake of data, you can find which of these logon events are the ones that stands out that you need to look into. Graphing. There's been a lot of great presentation on graphing. So we want to join the force and talk a little about it. John Lambert said many, many years ago, like defenders think in lists and attackers think in graphs. As long as this is true, attackers will win. I have one of these like super creative things or letter combinations in my brain. Or as Mom said, I have a creative brain damage. I usually connect things as a graph in my head. When I hear things like, oh, this is related to this one, a bit fluffy. So when I saw like a picture of a graph the first time, it was the first time I was able to explain how I think. So I not always care about details. I like to have the overflow graphing. usually as a defender, it's like, yeah, here's our list of vulnerable servers. And you start to take the list, patch them one by one, or reconfigure, or whatever it is. And then you have, yeah, this is a list of our high privilege accounts, but you don't have any correlation between this. So when you start doing graphs, you will start to prioritize your changes in the IT environment, because maybe it's not that vulnerable server that is most critical for us. It could be the other server that a lot of people can log on to that has some vulnerability that can be exploited to jump over to the next box or whatever it is. So it's super important to start thinking in graph if you want to protect your environment. Just for reference, example query where we actually do device network events to find how people are moving laterally using RDP in the environment. So what you can do is creating your own nodes, creating your own edges based on the data that you already have in Defender or in any other place where you have data. And then from there you can do the graph and add the filters that you need. Maybe you want to see the amount of connections or like the edges of the graph or the center of the graph or whatever it might be. But this can be done on everything. Maybe you want to follow an email all the way through and visualize this, how this email was forwarded or whatever it is. Teams messages, so there's so many things that you can use graph for. And in this example, I mean, not the same nice visualized way that both Henning showed and Olaf showed and Thomas showed. But this is the Plotlib plugin that you can run in ADX. It's a Python plugin. I made a few changes just to change how it presents the output. So this is a graph of process executions. But you can also do tables. So this is RDP flow. So you can use this as identity admin or server admin or SecOps to find how are people using RDP. Do they jump across like everywhere? Because everyone knows that RDP is ransomware deployment protocol. It's not something we want to see. Not that much, at least. So you need to get the idea how people are using remote connections and remoting in your environment. So you can use graph for this and find all the entry points for this lateral movement path that exists, for example. Detect anomalous spikes. I just want to share this. On Learn, there are tons of functions that can be used. So they have built-in training period and detection period, and you have so many things. Take one, try to use it, make changes, see how it changes the output, and see which one you can adopt and which one you can use for detection or finding other things. Right, so to get into some scenarios, we are again, yeah, the blue Adidas shows and the Kusto.
Yeah, let's go to the client admin guy, or girl for the matter. So this came through a lot, of course, during the pandemic. Everyone was going to work home. Things were, you're making a lot of noise, I think.
Is it mine?
I can cut the beard if you want.
Oh, there it is.
All right, yeah, so the local firewall. I mean, often we have misconfigurations. So customers take their laptops, they bring them home. Either they connect to 4G, or is it mine? It's yours, of course. 4G, 5G, and then the local firewall is allowing traffic inbound, so sitting there unprotected on the network. We have the other option, they bring them home, they have some NOP configuration on the router, the traffic is allowed inbound, or we have direct traffic hitting, they have like pass-through on the router, and then they're of course connected to the VPN, to the corporate network, they hit the domain controllers, they get the domain firewall profile for some mistake, And like everyone does, oh, if you're on the domain network, let's turn off the local firewall. We see this weekly with misconfigurations in customer environments, and there are simple tasks to identify it. You have the telemetry and EDR. So I mean, this is something for the client admins to look for, see if you have misconfigurations. So simple one for the client admin to actually get going. We have one query here, just checking the device network events. If it's the bottom one, if the remote IP type is public and we have an inbound connection accepted, of course we need to have the auditing enabled on the network events for the firewall, so we get the inbound connection accepted and so on. So that's kind of a first. We have the other one where we are not looking if it's a private, but then we missing all the NOT if there's an IPv6 to IPv4 conversion. And you need to do some filtering. But those two queries you can get started with and see if you actually find something if you have misconfigurations. I don't think we have one single environment where we don't find anything misconfigured with this. So definitely it's something to go home and look for. And it is very common. Either you have to reconfigure your NLS so you don't get the domain profile, or actually fix your firewall profiles, which is way better. But it could be a combination. We have some customers using Scalar. When they connect to Scalar, they get connection to the domain, they get the domain firewall profile, and yeah, for some reason they turn that off when being on the domain profile. So yeah, shit happens. And then...
Because it's on the inside, right?
Yes.
Nothing bad can happen on the inside.
No, exactly. That's it's secure on the inside, for sure. The other one is, of course, if we take all the threat intel reports, all the experience we have and so on, is about unmanaged devices. Threat actors, when they get in, they get to the unmanaged devices. Maybe we haven't been able to deploy Defender to them yet, or we have something on some remote network we forgot about. If you have 4 computers in the office, sure, it's simple. But if you have 50 offices, thousands of computers, there's going to stand some XP box, some other machine somewhere. And then how can I go about finding this? We just have one poor query here, which is really poor for the sake. I know we can do better in other scenarios, which we don't have a query for here. But in this case, we're just checking if the device is not onboarded. But that means that Defender needs to have found it with this device discovery as well. Another option to do it is actually to query, do any of my onboarded devices have a device that is not onboarded that have communicated with me on the local network? So then I can find other IP based on an IP basis instead to identify that. And that's usually very effective. Of course, you will probably have outdated operating systems where you can't install Defender and so on, because everyone has their NT4 domain still, right? Or what have you. We actually had one for a few weeks ago, but yeah. How it's needed for production, sure.
As Stefan said, do an anti-join with another list, and you can also, there's a function called device from IP, so you can get to see if it has a device ID, so if it's discovered or not. So play around with this and make sure that you know that you have the coverage that you expect, which should be close to 100%, except for instance, IT devices or whatever it might be that you might not monitor, even if you should.
And there's 2 aspects of it. Finding them, fixing them. The other one is, of course, creating custom detection. If someone is connecting through any of the management protocols from any of those devices, okay, maybe I should have an alert. Why did someone connect from this IP to my domain controller? Probably not a good thing, but yeah. So a good case to bring home and get going in your environment. Of course, we can see if we can share the other queries later, but this one is what we have for you today.
Some of the queries will also be released on GitHub if they haven't been already. So we'll provide a link with all the queries, full working or mid-research or whatever it might be. Another thing, how many of you are local admins on your devices?
Probably everyone, right? We're in IT, so why not?
He's my boss, I know. That's something you want to understand how it looks in your environment, because if you log on as a local admin, you can become system, and system owns everything. It doesn't matter what you do. So we have data to check if someone logs on as local admin in Defender. So you have the is local admin value that you can look for. So you can continue this query, and on this one, we do a distinct count, like we count unique devices that every user is local admin on. So we can find, like, oh, here's a user that logs on, seems to be local admin on all devices they log on to, which might not be good. So, and you can continue to work on this and map it even further with a graph and like connect all the things and do the anomalies, like, hey, this is local admin, this user is local admin on this device. That is an anomaly. So you can continue to work on that. So you can find misconfiguration based on these low-level signals.
Yeah, and also for the query, in reality, you will need to do a lot of filtering because there's a lot of this built-in stuff, and I think it's HP or Dell, they have their local temp account and so on. So
yeah,
you need to do a lot of filtering on that one, but
yep.
that depends on the environment. But you'll notice that when you get the results. But it's a good start for the client admin to get going at least, and especially driving down the number of local admins is a good thing. So, and then you should buy EPM, of course. We're in the Microsoft Office. We're selling. No, we're not. But you can use that query. So all right.
Identity admins.
Yes. We have a secure fence or whatever we have here. So
yeah, PIM or something. Yeah, don't get me started on PIM. Self-elevation. Yeah, that's not a boundary. Might still be needed, and it's not a bad thing. But if you want to talk security boundaries, we can discuss if that's really is. All right, so get one identity scenario just to showcase something. This could also be adapted to a SecOps scenario. So how many logons to services? Were you actually using RC4 encryption type instead of SHA-256? This can be used for Kerberoasting, for example. So what we can do if we find something that's actually using RC4 is to try to figure out which systems, the reason, is it because of legacy systems, legacy devices, or whatever it might be that is not supporting SHA-256? Or is it just because we've always done it this way? Which is just usually the like the real life why it is as it is. We became domain admin within 10 minutes on 4 different pen tests because of this configuration. And this is including the password cracking. It was not that good passwords, actually. So, so basically, if we look at it from an attack scenario, and yes, not a bad configuration practice, is a threat actor with line of sight to the domain controller will ask for a service ticket. The service ticket is encrypted with the service accounts that has the SPN, the service account's password. So we can take this offline. There are PowerShell tools. We build a custom tool for it. Mimikatz can do it. And tons of other tools. So you request the ticket, take it offline, and then you brute force it. How often do you change password on your service accounts? How many of you have less than 50 characters as password on your service accounts? And if you have less than 50 characters, you're probably at risk. The research we have done based on the pentest data that we gathered over the years is that we usually manage to break everything less than 14 characters of password. And we have the time until the next password change for the service account. And we see that they usually don't, most of the passwords that we actually break are more than 10 years old. So this is, I mean, this is the reality and something we need to adopt to. So usually we say 50 characters because you copy paste it and then you don't touch it. And try to use GMSA. GMSA is not a silver bullet, but it's better. the GMSA account, you need to consider like, all right, which devices can pull this password, and you need to like monitor those devices and so on. Another thing you need to monitor when it comes to service accounts is where the service accounts usually log on to. So in this case, let's say I'm able to steal a service account for a IIS server. So suddenly someone logs on with his service account from a device somewhere on the network. That's probably not a good thing and something you can detect. This is one example to pull it. We actually built and discovered during a ransomware scenario where they requested, I think it was 200 tickets within 2 minutes from one single device. So they pulled all SPNs, tried to get a service ticket for all these different accounts, and then they took it offline, and then they came back. So this is something that you can build as a detection rule, for example, to count the number of distinct tickets are being requested within a certain amount of time from one single endpoint. Or just get rid of the RC4. Tiering abuse. How many of you have built a tiering model in your on-prem Active Directory?
Too few hands, but yeah, of course, everyone has. I see that. Everyone has.
I want to say 100% just to like chase the ones at home.
Exactly. Really good. But yeah, I mean, there you can always do misconfigurations. One thing is to do just query for that. If you have naming conventions, you can see if some of the tier names are logging onto other devices, or even trying to, because it could be this sloppy admin or the lazy admin trying to log on to some device with their higher privileged account, if you have A0, A1, or what have you, depending on your naming standard. So checking if they're logging onto clients or servers outside of a certain group that is involved in that. So simply just checking for that. Then you can smack them on the fingers if they're doing something wrong.
To do another iteration back to exposure graphs, we have dynamically data for domain admins and domain controllers. So we can find all devices that are domain controllers and all devices that, or users that are domain admins recursively, which is really amazing. So we can build dynamic queries. We don't need to update this list somewhere and pull the data. So as an example, we can find all domain admins log on to non-domain controllers. And then we can discuss like, yeah, what about the PKI, Entra Connect, and so on. But maybe we can include them even if they're not domain controllers based on the services they provide and so on. So if you can, try to keep it dynamically, because if you have like a static list within your query, it's not going to be updated. It's going to be, and you're going to tell everyone that you're going to do it, at least when it comes to myself. Of course, this is easy. I'll keep it up to date. And then something happens like, oh, I need to focus on this one or that one, that thing. And yeah, then the list is old.
Yeah, and if you operate the service with multiple customers, then you're going to have a real severe headache. So that's, yeah. All right. So what if the Nigerian prince really needs my help?
I always respond to these emails because, I mean, it could be, this time it could work.
I mean, for the messaging admin, it's about making sure that you have proper configuration, identifying issues with threat policies or ETRs that are misconfigured, ways of doing hunting for this, of course, where do the email actually land, how are they flagged, and so on. There are some values we would love to have in hunting, like the SCL value and so on, which is not there today, but especially for managing spam, because, yeah, you really want to lower that, but if you harden it too much, it definitely ends up in user quarantine, and then you have to manage that. So it's kind of a fine-tuning. So we have some queries here as well for those scenarios to get you going and drilling into the data.
Also, fly some emails to the junk with the striked crowd or something, whatever it is on the picture. Yeah, so just to share some examples of what you can do. I mean, looking for, when you look at the emails, you have a key value that you have through all the email tables, the network message ID, for example. So it's a key value that you can join on, which is amazing. You also have the email cluster ID. So you can group emails based on the cluster ID. So you can, for instance, check on all the cluster IDs that have different delivery locations, which could be due to some misconfiguration in your transport rules or whatever it might be. So for instance, Stefan receives an email and I receive the same email, there are still different actual emails being sent. For Stefan, it's being blocked. And for me, it's being delivered. So you can find these ones. So you can find undetected emails. You can find misconfiguration. It could be that it's given to me because of a transport rule, for example, because they will override all your security in email. You can use this one just to count the emails with threats, count the number of clicks per email or per sender domain or whatever. So you can see, yeah, we do receive a lot of bad emails from this sender or this domain. It catches this percent of the emails and so on. So if you need to go through and make changes to your spam levels and so on, then you have this data that you can sort of rely on, or feel free to change the query to get the output that you really want. But this is the way that you can work. So you shouldn't arbitrarily just change the spam level. You should do it based on the actual data that you have in your environment. Here is some data on the delivery locations. We can also find, since we have the post-delivery events, we can see what happened with the email after it was delivered. So if it was delivered to quarantine, how many releases do we have of the email, or how many inbox and then SAP? If it's a lot of SAP emails, maybe we need to configure the different protection configurations that can be done to be able to lower the rate, because it doesn't matter if an email is SAPed. We usually see that within 2 minutes, the user are clicking the email, and they click on junk. So maybe you should stop using junk and send the emails to quarantine instead, so you add an extra abstraction layer where the user have to go on and release if they can release some quarantine emails by themselves.
Right.
Average time to quarantine, and there's so many things that you can do with this data.
We have another one, anti-spam tuning, so we'll click through this one. So another query, definitely something you can use.
This is quarantine released per day. So maybe it's something, we don't want to do this extra job and release it from quarantine if it's an admin doing it. Oh, maybe we should change some configuration so we lower this. All right, working in cybersecurity is not stressful at all. Peter, 31 years old. Looks like him, right?
Yeah. However, I am a bit older than 31. I have to admit it, though. But,
so emails with alerts and clicks. How many of you are looking at incidents and so on in Defender? How many of you think that the URL click incident is instant? Or is it a delay before it happens? A short delay, sometimes, not always, of course. And sometimes it's not even known that it was a bad email.
now you're being nice. So.
Yeah. I realize it's recorded, so. Email is released, and the user is clicking the trigger happy. I need this. This prince guy that wants to give me money. I just need to send them some. So they're clicking. So we can actually detect the. If you look at the detection, this is an email with a malicious URL. Then we can instantly find if someone is clicking before we get that alert. And we can also once again, go back to the cluster, and we can do subject. We can normalize the subject and find other emails or similar emails. Maybe some similarities can be done to find similar subjects from a similar sender or similar sender name. Or like where they try to make it look like someone internal that's sending this email. We can do similarities everywhere. All right, so another scenario, RDP change. We mentioned it a little bit earlier. So for instance, we have an external threat actor, and we had RDP exposed to the internet. Ta-da! And they got into the server network, they jumped, end up in the factory network. This actually happened in a pen test we did. It was super fun, and it was all these like fabric icons and stuff. So I was Stefan like, can I push it? I like to push buttons.
It wasn't really a factory, it was a SCADA system controlling a city, but yeah.
Yeah.
Factory.
Yeah, but it was like a factory icon. And it was all these kind of crazy numbers and stuff, like visual stuff. So I actually hold my mouse like this to not accidentally click on a button, because it was like some electric generation thing for a city, and I realized that something can actually blow up, which could be cool, but
and it was
if someone else doing it. And then they actually called us, I think it was 4 weeks afterwards, like, yeah, we got a anti-malware alert in this. We told you not to go to this system because it was actually out of scope, that IP network. But routing and so on, it wasn't that easy. So we actually went to one server that we found like this documentation on the network map. And that actually forwarded us into this forbidden network.
Network address translation. All right.
Yes.
So let's go to the query.
All right, so this is, again, so we do, just to create the node, we do device network info. And we added this just for, I mean, we're not including this in the output, but just to show you how you can package some strings into, depending on how you wanna have it. And then we unpack it again. But I'm actually reusing this part for a lot of identity stuff. And especially when you have like an array, you say array 0, 1, 2, and so on. And then you have like a name and the value. But I want to have the name and value only, and not like, oh, maybe it's array number 1 this time, but next time it's 1 because another value before. So we can do this just to get rid of all the array number things. All right, and then we do the edges. So we actually do the RDP. No, it's an inbound connection accepted. Yeah, and 3389, the ransomware deployment protocol port. And then we do the edges, and we do make graph, source to destination, and so on. And the cool thing here, since we look at the inbound connection, we don't care if the device is onboarded. So this can actually come from, you know, the internet-based device that we don't monitor. So the attacker device. And then we can do like, yeah, it should be a certain amount of jumps and so on. What we're not doing here is to look at the session. Since graph is actually time-aware, we can actually see in which order this things is happening. So in reality, this query will see if, yeah, there are RDP between these IPs. It's RDP between these ones and these ones, but not in a certain order. So the uses of this is like, yeah, there is a way to go like this. But if you want to do it properly, you want to do the session that the user log on to, and you also want to check if they flip session and maybe impersonate another user and so on. But hey, then the slide's going to look nice, right? So how deep is this rabbit hole? Like, it's really deep. I really encourage you to look into all these functions or build your own functions that suits your need. But you can get so much ideas how to work with functions and so on. And like in Defender, you can save the function, so you don't have to have it in your code. That will make the code much easier for the next person to read. And you can reuse it and so on.
And the rabbit hole is very deep for sure. I've gotten text messages from Mattias 5 in the morning. Oh, I found something.
Yeah.
So it can be very deep for sure. So
I called Henning 5 o'clock in the morning before a session, like, hey, why doesn't this work? He was awake.
so well
It's graph semantics. How hard can it be?
So start working with it.
Exactly. So the vulnerability analyst. I mean, yeah, vulnerabilities are increasing definitely. So you have a lot of data, use it. I mean, finding end of support, end of life. I think we have a query here as well to show some of it. I mean, it is. There's what you need in there.
The last patch applied, also the last device update, so you can see if maybe devices haven't been online, so that's why it's not updated. We can look for end of support software, but don't forget to join to find how it actually affects organization based on other connections that you can do and other correlation you can do. Built on exploitable and so on.
Public IPs. I mean, we have tons of Azure infrastructure. The vulnerability team is, well, how many public IP addresses can you have? What are we using? So you can actually leverage Azure Resource Graph to pull all of that data. So if you go into Azure Resource Graph, you can query the resources for the public IPs. Of course, we don't know how long they're going to live, but at least we have a list, and then the vulnerability team can start scanning. So another place to actually query for data to get hold of this. And this is, we often meet this with the vulnerability analysts. Oh, we have so much cloud infrastructure, we don't know what we're going to scan anymore because it's out of our control. So you have actually that in the resource graph to pull it. So, right.
I try to look like instant over on the.
You have 2 minutes for your functions.
Yeah, absolutely. The function thing, two main. Tabular, where we extend our result with new columns. Or you have Scalar, where you want to set a value to a certain column. This is actually the function that was used for the magic thing. So this is actually an XOR function that you can use. Maybe you do some reversing or whatever using Kusto. That's where you do it, right? So this is an XOR function you can use. I think this might work on Cisco Type 7 encrypted passwords. All right. It's not that slow. I just had to be cautious when I click. So defenderboys.com was the encrypted message.
So if you want to find our blog, that one leads there. Otherwise, it's blog.seclabs.com. But yeah, someone founded the name Defender Boys for us, as we were always presenting together on Defender. So now it's Defender Boys. So
just to show some fun things you can do with. Oh shoot! We need to move it over here. All right. So.
30 seconds.
Yeah, so something like this. Oh, I need to. Yeah, so we can do smileys. And let's see if we can. Can't remember what this was. Yeah, some cool output. If you want to do like audio stuff. But I mean, it's almost Christmas. I'm just gonna. Hey, it's almost Christmas. It's time to go. Oh shit, did I break it?
No.
Oh. Yeah. And so we cut down the tree. And so what's the next step? We need the ornaments, right? Let's add some ornaments. This will not work in Defender, in the scatter shot there. And we're gonna finish up with, I mean, we need a star on the Christmas tree, right? So.
And the audience claps.
Whee! Yeah. It worked.
It worked.
This was prediction, right?
Yeah.
Again, thanks to all the sponsors. I mean, it's amazing to be here.
Yeah. Thank you very much for listening. Hopefully you learned something. So.